All right, so like I said, it's the third assignment in my math lab, 5.66, solving equations using decimals or containing decimals. And really, for the most part, you'll be following the same procedure, same processes. If I have x minus 1.5 equal to 8, I'm going to add 1.5 to both sides. When we talked about using the opposite operation in order to solve, that 1.5 will cancel on the left. And then 8 plus 1.5 is 9.5. So don't let the decimals, freak you out.
Quick question. So when we
Mm-hmm.
do this and we have a whole number and a decimal, it's okay to just straight add it down?
Mm-hmm. Because when you look at what you would do here, as a matter of fact, this would be 8.0 and 1.5. Are you talking about because of
Okay, got it. Yes.
yeah. Mm-hmm.
Thank you.
Yep, no problem. Yep, you line up your decimals. That'll take you there. All right. Negative 2y equal to 6.7. All right. So divide both sides by the negative 2. Guess if I stay consistent with what I was doing, that'd make that red. And those negative 2's will cancel. And I believe that's negative 3.35. Let me make sure I'm right. Yep.
This would be the part it would be okay to use a calculator for, right?
Yep. That will be fine. Yeah, I'm not gonna take you all the way back there, y'all.
Just asking.
No, but it's a legitimate question because because since this is that type of course, then yeah, some structures may say no calculators at all. I believe, let's say if we were in class, you would get the regular four function calculator that, when you say four function, those, as long as they have, those are the main things that they have. So in other words, something you could easily get from the dollar store, but you still could, like you said, you still could check that with that, basic four function calculator. What they
Okay.
wouldn't want you to have is an actual scientific calculator or a graphing calculator, where pretty much you probably could throw that in there and just be done and walk away from the from the computer. You know what I mean?
Okay.
So yeah, but it's not a problem with checking your work and everything. So the process is what's most definitely emphasized. And so when you talk about sending your scratch work, we be looking for those steps, but
Okay.
not necessarily, what you just finished mentioning that part. Yeah, we're not looking for that. So
Okay.
yeah, good question, good question. So here we have 7x plus 3.2 equal to 4x minus 1.6. So follow your procedures, same procedures. Decimals doesn't change that thought process. So you have four different terms here. It doesn't matter which one you decide to move first. Just make sure you correct with your mathematics and you'll get the same answer. I'm going to rewrite it right here. And I'm going to go ahead and move to 4x. So I will subtract 4x on both sides. That'd be 3x plus 3.2 equal to negative 1.6. Now remember, I didn't mention this, but same thing that we did before. Remember your goal when you have these, multiple places where your variable is located. You want to make sure that all your terms with your variables are on one side, all of your terms without the variable are on the other side. So my goal is to get the 7x and the 4x on one side, 3.2, and the 1.6 on the other side. So I decided to take my 4x to the left. So I subtracted 4x from both sides. So now I need to take the 3.2 to the right. Now remember, the way we were doing this is by using our opposite operations. I had a positive 4.x, so I subtracted 4.x from both sides. I have a positive 3.2, so I'm going to subtract 3.2 from both sides. Now, if I wanted to move the 1.6 to the left side, then I would have had to add 1.6 because I had a negative 1.6. So just re-emphasizing the idea of using these opposite operations in order to get the desired result. And so we're just going to add those because they have the same sign. Negative 1.6, negative 3.2 is negative 4.8. And then to finish it off, divide by 3. X is negative 1.6. All right. Do one more like this. All right, so I'll show you one more way of doing this, another way of doing this. Excuse me. Now, you always have the option of just solving your equation the way you see it with the decimals involved. Since you're not completely removed from using your calculators, you can just do that. Now, if you wanted to clear out your decimals, you could do that as well. So I'll just show you this way. You don't have to use it. It won't hurt anything if you never use it at all. Just like with clearing out your fractions. Remember, we talked about that last class. Clearing out your fractions, you don't have to use it, but helps. It helps. So let's look at clearing out the decimals. So first, so we want to find the maximum number of decimal places. And what I mean by that is that when you look here, you have one decimal place, the tenths place. Here you have one decimal place, but here you have two decimal places. So in this case, it would be two decimal places. All right. Then you're going to multiply. All right. All right. So then you're going to multiply each term by the multiple of 10 based on the max number of decimal places. So in other words, the number we're going to use is 100. So we have, and that's based on the two decimal places. So we had 3 decimal places, it would be 1,000. If we had 1 decimal place, it would be 10. How many zeros you have will be based on how many decimal places you see, the max number of decimal places that you see. You know, if we had 4 decimal places, then it would be 10,000. You multiply each term by 10,000. All right. So let me show you how that looks. So we like 10. I got a problem over here. All right, so we multiply 100 to each one of our terms. Remember, each term has to be multiplied by that value, or you will be changing the value of the equation. And then we simplify. And that'll be 50y. 230. And that's 165. All right, questions on the process before we go ahead and solve. Outside of that, it's the same steps. I'm going to subtract 230 instead of 2.3. Remember before it was 2.3. Then I'll divide by 50, but before it was 0.5. Either way, I would still get the same answer. But, you know, some people like to clear out the decimals. And just in case my math lab asks you about the process, then that's the process. So let's go ahead and solve. We subtract 230. Yeah. So 50y equal to 65. And divide by 50.
Mr. Tucker, isn't that supposed to be a negative 165?
Yeah, I was just testing y'all to make sure everybody's paying attention. That's how that works.
No.
Thanks for the catch, though. Yes, it should be a negative 1%, negative 65. Appreciate it.
Yeah,
Appreciate
right.
it. Say that again.
I said, yeah, right.
I don't know if he caught. I think he just let me have it. I don't think he really caught it. But yeah, appreciate that. Yeah, if you guys ever see something like that, let me know so I can make sure that thing is straight.
I caught it. I just thought she was gonna fix it. I thought wasn't done writing.
No, I think I think I missed that one. I'll be honest with you.
That's okay. We would have got a point off though. There, yeah. Mm-hmm.
Well, you know, see, the way that works is oh, and I said, I don't know if I mentioned that to you guys. If ever there's anything y'all want me to check as far as points and stuff like that, you know, something you might feel like could have got partial, or if you have any questions about anything, just let me know. We can discuss it, or I can go look at stuff and tests and everything. I can add points accordingly if you know it's seen as, you know, points I deserve. But of course I wouldn't know unless you tell me. So yep. But my math lab most definitely would have marked that wrong, completely wrong. So if you do have an idea that you think you may deserve a partial credit or something like that, you got to let me know. Because like I said, my math lab would have marked the 1.3 completely wrong. All right. So now this one says, any questions before we?
Yeah, could you scroll all the way back up so I could write that information down?
All right. Tell me where to stop.
The one that says clear
Out decimals.
Yeah.
All right, there you go.
For some reason, the way you clear out the decimals to me, it really makes it easier than trying to do it the other way. I don't know if it's just the zeros or what it is.
Oh yeah, yeah. Well, like I said, some people prefer it, and there's nothing wrong with that. There's nothing wrong with it at all.
All right. Thank you.
Yep, not a problem. Yep.
That's
So
the first time I've seen that done. It's just a lot easier
oh,
to
okay.
me.
Well, I'm glad I could help you out there. Yep. And just like with the fractions thing, a lot of people like to clear out the fractions because they don't feel like dealing with them or don't want to deal with them or whatever. Yep.
And you just
Same.
do the reciprocals, don't you? For the refraction.
When you talk about clearing out, it depends on how many steps or what the complexity of the problem. Because if all you had was 5/9 y equal to 10, then you would do the reciprocal. But if you had -1, now you need to multiply each term by 9 so you can cancel out this 9 down here.
Okay, got it.
Yep. Remember that was when we were talking about clearing out a fraction. We had to find the LCD and multiply each number by the LCD.
Okay, which would be 9 because it's one.
Yep.
Yeah.
Mm-hmm. All right, so let's look at you guys' favorite topic in math, which is problem solving.
Mhm.
Oh, God.
And this is coming out of 9-4 and 9-5.
This is not going to help.
We got enough rest yesterday, I guess, huh?
I got a little bit. I mean, an extra day wouldn't have hurt.
Yeah.
All right, so let's look at some steps, strategy. Let's see. All right, so strategy. Of course, you want to read the problem. Make sure you understand what they're asking of you. Read it as many times as it takes. Nobody knows how long or how many times it took you to read it, so nobody's there in your head with you. So make sure you take all the time you need to understand what they're actually asking of you. Then you want to establish your unknown and write each one of your unknowns in terms of one variable. What you do not want to do is introduce like multiple variables into your situation, because the more variables you have, the more equations you will need to solve. Then you'll need a system of equations, and we don't want to deal with that right now. And all the ones that you guys will be dealing with, can be created with just one variable. And so that's what we want to stick to. Then you write an equation, and all this stuff will be based on the words that are in the problem. Then we'll solve and we'll check. Now, check is important because you want to make sure you've actually answered the question. Now, it is possible to solve and be right and correct in your solving, but still have not completely answered the question, because let's say you solve down and get X, but then they ask you for what is the measurement of each, blah, 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 blah. Well, one answer is not what they're looking for. They're looking for multiple answers. So you would take what you solve for, and that will help you to find your answers. So you'll see what I mean as we do a few. All right, and the reason why I put an asterisk beside 2 and 3 is because 2 and 3 is where most people have the most trouble. And once you get down to 4, that's pretty much what we've done, previously in the previous sections, just solving your equations. But establishing what your unknowns are going to be and how they should be represented, and then writing an equation, a lot of times is where a lot of people have trouble.
Feel slow because I'd be stuck.
Well, hopefully, that won't be the case this time.
I've been staring at the screen forever, it seems like, trying to figure it out.
All right, so we have, didn't write the other part, find the number. So we have twice the number added to 7 is the same as 3 subtracted from the number. Find the number.
Oof.
just take a deep breath. Just woosah for a second.
I know one part. They say twice and 7. That's 2 and 7. 3,
right.
you understand? I had to recognize the numbers.
Well, that's half the battle. Because if you didn't recognize the numbers, that would be a problem as well. So first of all, we're gonna let x be our variable. It doesn't matter if you want to use A, B, C, D, E, F, G. Just a variable representing a letter representing the unknown that we're trying to find. And so we're just trying to find a number here. So x is going to represent the number that we're looking for.
2x.
So that's actually step 2 right there. That's the only thing that we're looking for is that number. And so step 3 is to write an equation. So in this case, it says twice a number, which is 2x, added to 7, plus 7, is your equal sign, or is the same as. In this case, they gave us is the same as. A lot of times they just say is. 3 subtracted from the number. So now if you're going to subtract 3 from the number, you wouldn't do 3 minus x.
3 minus 5.
Yep. You do x minus 3.
Because x is the number you're looking for.
Yep. And you're subtracting 3 from it.
Right.
Questions on the setup before we solve? All right. So now we'll just go ahead and solve this equation the way we normally would. Subtract the x from both sides. And subtracting 7. X is equal to negative 10.
Oh, I did it the wrong way.
What you mean?
Because
Say what? You broke up.
I said I did it. I guess I did it as a regular equation. X equals 5. I divided it. I didn't. That's because I went ahead. You understand?
Gotcha. Mm-hmm.
I got to go back and erase. Let's see. Don't move yet. Give me 2 seconds. Got that part right. I was calling myself trying to do it on my own. I did it the wrong way.
All right. So let's do another one.
All right. Yeah.
All right, so we have a 10-foot board is to be cut into 2 pieces so that the length of the longer piece is 4 times the length of the shorter. Find the length of each piece. Give you a chance to write it. All right, so let's look at what we have here. We have a 10-foot board. All right, we want to cut it into 2 pieces. Now, notice it says that the 2 pieces need to be cut in such a way that the longer piece is 4 times the length of the shorter piece. So what we can do is let the shorter piece be x. And if we let the shorter piece be x, that means the longer piece should be what for us?
3.
Hmm?
3/4.
I get what you're doing, but there's a way to represent that in reference. See, you're doing 3/4 of the 10 feet, but how would you write it in terms of x?
X times 3.
X times 3.
Now look at it. It's 4 times the length of the shorter.
Oh, 4
What did we
times
say the shorter would be?
4x.
X.
If the shorter is x, that means the
4 times X. Okay.
Yep. So remember, when we're talking about these unknowns, if we have multiple unknowns, we're going to call one of them the variable, let's say x, and then the other ones are going to be written in terms of that x. All right. Questions on what we've done so far? Make sure we're okay.
Should we do another one?
Nah, after this one, we done. I'm out of here. No, we got a few. We got a.
I don't get the concept of this right here, though. When you say 4 times, so whatever in the problem, whatever number it gives you and says times whatever, you always have to always use that as times whatever your variable is.
Well, of course, what you do always depend on what's being said to you in the problem. I
Uh-huh.
can't say every single time because I gotta, it always depends on what's being said.
Well,
It's
this
just that
particular.
this one, you know that you don't know anything as far as what the numbers are that are associated with your missing pieces. So
Right.
you know you're gonna have to call one of them X.
Okay.
Now the thing about it is the what dictates that is how the words are set up. So let's say if it said the shorter piece was half of the longer piece. So in that case, you will let X be the longer piece, and then the shorter piece would be 1/2 X. You see what I mean? If it said the shorter is half of the longer piece, right? So that means since the shorter is given in terms of the longer, you would let the longer piece be X, and then you would write 1/2 times X. So now what's going to happen is we're going to solve, and we'll solve and get X. Let's say if we solve and X was equal to 12. Half of 12 would be 6.
Okay.
So it just depends on the wording. Really, and that's what all of this is going to be dictated on. What you do will be determined by the wording. And we'll most definitely do more. I mean, we have plenty of time. We're most definitely gonna do more. And then also your, you just jumping into it, whether it be because you haven't seen word problems in a long time, or you never got it before, whatever the case may be. You got to allow your mind to be shaped into your options. You know what I mean? You're just seeing it for the first time in a while, so now you have to okay, what are my options? So just because you don't get it now does not mean you're not going to get it later, and you have to give your mind a chance to process. You know what I mean? And so right now we're just showing you what your options will be when you start to see these words and everything. So once again, don't get discouraged. I'm just saying this is to the whole class. Don't get discouraged because you will get it. Just give yourself a chance to. You know, like I said, sometimes, you just have to let your mind be shaped around what your options are, how you would do that when you see certain words and, what scenarios that will come across. So, so when you see this type of scenario, this is how you would, attack the problem. So now you're talking about setting up an equation. We have an algebraic representation for the short piece, algebraic representation for the shorter piece. Now, if you notice the way that it's set up, we have this board that's 10 feet long, and we've broken it up into 2 pieces. And both of those pieces should add up to give me the 10 feet, right? We're talking about, not worried about debris and all that stuff taken away from it. Um, Shavings or whatever the case may be. So you're looking at X plus 4X equal to the 10. Make sure that makes sense. Is everybody okay with that? Because once you have your equation set up, then you will go ahead and solve. And X plus 4X.
5X
Now just rewriting it down here.
equals 10. We're going to divide top and bottom.
Divided by 5. I think I heard somebody say that. And X is equal to 2. Now we have X equal to 2. Now you have to ask yourself, did we answer the question? Remember I say you always need to check that. And notice right here. Did somebody say something?
Now you gotta multiply 4 by 2.
So it says find the length of each piece. I'm gonna write this down here. We established that the shorter piece
is 2.
Was X, and since X is equal to 2, that's going to be that one, 2 feet. And then the longer piece Now, don't forget, when it comes to my math lab, it's going to ask for both pieces, not just one. So don't forget that. Or another way you could have found the longer pieces that we know we recognize the shorter piece was 2. We could have subtracted 2 from 10. Remember, they're supposed to add up to give you 10, and you still would have got the 8. All right, questions before we do another one?
Professor, that says total number in what?
Total number of Democrats, DEM.
Okay.
Yep, I just try to shorten it up. And then the other one, REP for Republicans. All right, so we have, as of 2017, the total number of Democrats and Republicans in the U.S. House of Representatives was 435. There were 47 more Republicans than Democrats. Find the number of representatives from each party. All right. So we have 2 unknowns here. And make sure everybody written it. I'm good, I'm good. Okay. We have the number of Democrats, number of Republicans. All right. So the key phrase that's going to help us here is that there were 47 more Republicans than Democrats. So it means one of them is going to be X for us. There will be our Democrats. And then if there are 47 more Republicans than Democrats, we let our Democrats be X and let our Republicans be X plus 47. All right, make sure that's okay with everybody.
And you do that because you got to assign the Democrats a variable. So it'll be X, A, B, C, or whatever. Okay, I just want to make sure I'm on the same page.
Yep. So each thing that you're trying to find, each unknown has to have some type of algebraic representation.
Okay.
Whether it be just a variable or a variable and something else. So we see in this phrase that there were 47 more Republicans than Democrats. So it's describing the Republicans in terms of the Democrats. So we would, call the Democrats X and then look at our Republicans and say, since there were 47 more, do x plus 47. So that means when I come down and solve for x, just like when we did with our board, once I come down and solve for x, I plug in x and I will also have the Republicans.
Okay.
Mhm. All right. So now, writing an equation, the total number of Democrats and Republicans is 435. So in other words, when I add my Democrats and Republicans together, I get 435. So x, and I'm just putting parentheses here just to signify my pieces. So x plus 47 is going to be equal to 435.
Got it. Okay.
Cool. So that's the setup. Parentheses aren't needed. Once again, I'm just using that to signify what was added together. All right, so before we solve, questions? All right, so go ahead and solve it. Go ahead and add our like terms. X and x is 2x. Subtract 47. What, 388. And then divide by 2. Got 1, yep, 94. All right, questions before we look to finish it off? All right, so once again, this wanted not just x, but it wanted the number of people in each party. So we know that 194 is going to be the number of Democrats, and 194 plus 47 should be 214, 41 would be the number of Republicans.
Okay, got that part.
All right, so let's look at another one.
When we write that answer, would it be x equals to 241 or just 241 by itself?
My math lab should give you a box for each one. It should. Matter of fact, let me see something real quick. I can see how they're asking you. Okay, that one didn't do it. Okay, so that one's not like that. Don't tell me, Okay, they didn't put 9.4. They didn't put word problems in here like they should have. Okay, I'm gonna have to put some in there because you guys, they're gonna be asking you guys about word problems. So yeah, but let me create that assignment because like I told you guys, we're doing this pilot. So they missed one section, which is 9.4.
Well, sorry, I asked that question.
Well, no, I was gonna find out anyway.
No moment, please.
No, because I'm gonna have to. I was gonna find out anyway, so it's all good. It's better to find out now than not to find
I'm
out.
sorry, class.
It is not your fault. I would have found out. It's all good. It is all good. Yeah, because I would have went to go create the test because you got to remember these developmental courses. They're asking you guys for certain skills. And so when I go to generate this test, if that wasn't in there, then I would have had to put it on the back end. So it's, it's better to go ahead and have, at least now you have the time, the requisite amount of time to work on it.
So when it comes to that, when the question that I asked, you can't really answer it because you don't know yet because it's not in their system, or would I just put it as a whole number, or will we write X equals 2?
Give me 1 second. I can go in it right now. Assignment manager. Come on. Nope. Sorry, y'all. It's taking a while. Here it goes. This is a good example. Has it shared yet? There you go.
Yes.
All right. So yeah. So you see how I give you a different box for each. What's the length of the first piece? What's the length of the second piece? What's the length of the third piece?
Okay.
All right. Because that answers your question, right?
Yes.
Okay.
I'm thinking. Well, yeah, because if it's already in, well, I guess that would already be in the question itself. We would just have to put the number in there.
So the one we just finished dealing with, it would have said Democrat. What's the number of Democrats, and then the other one, what's the number of Republicans? Yep.
Right. Okay.
All righty. Good question. All right. So let's go back to our notes. Okay. All right, so let me get out of here. And talk some more. All right, so sorry, I had to sneeze. I didn't want to sneeze in you guys' ear like that. All right, so in 9.5, let's see, do we want to do another word problem? Y'all. We can do another word problem. All right. So if the two walls of the Vietnam Veterans Memorial in DC were connected, an isosceles triangle would be formed. The measure of the third angle is 97.5 degrees more than the measure of the two equal angles. Find the measure of the third angle. So when you're talking about an isosceles triangle, it's a triangle that has two equal angles. And so when we look at what's going on here, so we have a triangle with two equal angles. So now what we can do, if you look at this, now let me go back. Remember our steps. We need an algebraic representation for each unknown. Now we have a triangle. That means we have three angles. So if you want to write all three, first angle, second angle, third angle. Now, two of the angles are going to be equal. So what we can do is call both of those x. And it says the third angle is 97.5 degrees more than the measure of either of the two angles. So when we're talking about this third angle right here, if it's 97.5 degrees more than, that's just going to be x plus 97.5. All right, questions?
So the answer to this question would be x plus 97.5.
Well, it wouldn't be the answer. That's just the setup.
Oh, just set up. So it says find measure of the third angle. So it's not asking us to give an x like.
Well, we need to figure out what is x so we can have an actual number because we have to have whatever x is plus 97.5.
Oh, okay, so we're not done with the question.
Right, right.
Okay.
So now we need to set up our equation.
All right.
And the way we do that is notice it didn't say anything about anything else except for the fact that we're dealing with a triangle. And some of you may remember from geometry that all angles in a triangle add up to 180. And notice they didn't mention that, but they expect you to know that. So whenever dealing with a triangle and its angles, very rarely do they even mention that those angles add up to 180 because they expect you to, know that part. So just throwing it out there. So it means we're going to add each angle and set it equal to 180 degrees. All right, so now before we solve, questions on the setup.
Not yet.
All right, so we can go ahead and solve now. Combine our like terms. 3x is equal to, not equal to, 3x plus 97.5 is equal to 180. Subtract 97.5. And that's going to be 82.5 for us. Divide by 3. X is 27.5. Yep. All right. Questions on the solving before we check to see if we've actually answered the question. All right, so we have x is equal to 27.5. You go back to your last sentence and see what they want from you. It says find the measure of the third angle. So this time it doesn't want each. You know, a lot of ones that we dealt with previously said find the angle of each or find the measure of each or find whatever of each. This time angle 1 and angle 2 is not what they're looking for. They just want the measurement of angle 3, that third angle. So third angle is x plus 97.5. So that's 27. Oh, yep, 27.5 plus 97.5. And that result should be 125. Mm-hmm. All right, questions. All right. So that was really 9.4, but I'm looking at something from previous class. See how we did it. Okay. Oh, what's it from another section? Okay. So next class, well, that was really just 9.4.
Oh, you talking about the section number?
Mm-hmm. Mm-hmm.
Okay, 9.4. All right.
And so next class we'll do 9.5 and probably 9.6.
So can I ask you this 125, is that the two x's that we don't know what, is that the two other variables for other sides?
No, that's just 27.5 plus the 97.5. Now, if you're talking about all your angles added together, remember angle 1 plus angle 2 plus angle 3 is supposed to add up to 180.
Right.
So 27.5 is angle 1, 27.5 is angle 2, and 125 is angle 3.
Got it.
Add those three together, you get 180.
Okay, I was trying to figure out what that meant.
Mm-hmm.
Let me write that down. 1, 2, 3.
Mm-hmm.
2 seconds.
Mr. Tucker, do you have some time after this class, like 5 minutes, to go over a problem on the homework? Okay, thank you.
Okay, you can keep going. Thank you. I got it.
All right. So anything else before we close out? I'll close out. Anybody want to stay back for her question, and you are free to do so. Because it was just a question on you said the homework. So
Yeah.
yeah. So if anybody wants to stay back for her question, feel free to do so. Outside of that, it's 10:44, and hope you had a great weekend. Hope you have a great day. I will see you on Thursday for those who are going to go ahead and check out. All right, have a good one.
You too. Bye-bye.
All right,
Later.
take care. All right, so what was your question?
Alrighty, so I had a question starting on number 7 and number 8. I know, like, I seen on my math lab, I couldn't get it right for some reason.
Okay, let me see what they look like. In the first section, 3.
Yes, so it's 3 parentheses y minus 3 parentheses equals y minus 9.
Oh, hold on. I didn't know you were gonna give it to me. All right, so you said 3 parentheses.
Y minus 3 equal to y minus 9.
All right, so is that it?
Yes.
Okay. All right, so let's go ahead and solve. First thing you want to do is distribute. You got 3y minus 9 equal to y minus 9. Now you want to get all of your variables on one side. So you can subtract y from both sides. All right. So we got 2y minus 9 equal to negative 9. You okay so far?
Yes.
All right. Now we will add 9 to both sides. 9s will cancel. That'll be 2y on the left, but also 9s will cancel over here. That'll be 0. Finish it off, divide by 2. And y is equal to 0.
Okay, forgot about the when you divide by 0, it's 0.
Oh,
All right.
okay.
All
Gotcha.
right, this is such a simple question.
Oh,
All
yeah,
right,
nope.
thank you.
Okay, not a problem at all.
All right, thank you, Professor. I'll see you Thursday.
All right, take care.
All right, you too.
Can you explain the word problem again? 'Cause I kind of got lost on the word.
All right, what you mean? Which one?
Can you go to the first word problem that we did?
All right. This one?
Yes.
All right. So twice the number was 2x.
Okay.
And then added the 7 was plus 7. Then it says it's the same as, that's going to be your equal sign.
Okay.
And then 3 subtracted from the number. So the number we had was x. So if we're going to subtract 3 from it, then it'll be x minus 3.
Gotcha.
All right.
So the same as means equal.
Uh-huh.
Okay.
All right. So then from there, you solve it like we did previous sections. You would subtract x from both sides.
What
And
do we
then
subtract? What do we if we subtract 2 from each side? Would it still give us?
Yep, still get the same answer. It's just that you would have opposite signs than I would have, but ultimately you still would come down with x equal to negative 10.
Gotcha.
You know, when everything's said and done. Yep. All right.
Okay.
All right. So are you good to go, or are you?
Can you explain the boy? Because the boy I was lost on too.
Okay. So you got a 10-foot board.
Okay.
Board is 10 foot long, and you want to cut it into two pieces.
Mhm.
The length of the longer piece is 4 times the length of the shorter. So here's my board right here.
Right.
If you call the shorter piece X, it tells us that the longer piece is 4 times X, or 4 times the shorter piece. So that's what I have right here. I called my shorter piece X and then called my longer piece 4 times X.
Okay.
All right. So now, so you okay with that relationship? Make sure you're
Okay. So that.
Mhm.
Okay. So so 4 times is the longer board and X is the shorter board.
Mm-hmm.
So how did you make that into the word problem?
You talking about the equation?
Yes.
Okay. So I just want to make sure you were okay. So you're okay with that relationship with X and 4X before we go to the equation?
Okay.
Because I just want to make sure you're okay with the setup before we go, because this is the foundation of our equation. So, you know, the way you're going to set all of these up, let me see, did we do it in the last one? Didn't have to do it in the last one. Just like in this one, notice we only using one variable, X and X. And
Okay.
all of them, we only using one variable, even with these angles, see X plus 97.5. So what you don't want to do is call the shorter piece X and then call the longer piece Y, because then you have to, then you have to introduce more equations in order to be able to solve.
So they're both X.
Yeah, right. So all of them are going to be X or written in terms of X.
Okay.
So
How do you know which one is tons of X though?
all of it is going to be based on the wording. So you're gonna have to get used to how things are worded and what your options are when things are being given to you in those words. You know what I mean? And so it may take a little time. You know, you don't beat yourself up if you don't get it immediately right now.
Okay.
But you want to look at the process. Notice how it says the longer piece is 4 times the length of the shorter. So the longer piece is being described in terms of the shorter piece.
Okay.
So the shorter piece we let be X.
All
And
right.
then we describe the longer piece in terms of X.
All right.
So which was the 4 times the length of the shorter, which is 4 times X.
Gotcha.
And so from there, we know the board altogether is 10 feet. So
Okay.
we know both pieces should add up to give us 10 feet.
Okay.
And so that's how we set up our equation. Shorter piece plus longer piece is equal to the whole board. So in other words, X plus 4X is equal to 10.
And that's how we got X too. Okay.
Mm-hmm.
Okay.
All right. So from there, you solve by adding your like terms. X plus 4X is 5X. So you have 5X equal to 10, and then you divide by 5. And then that's how we got to 2.
Okay.
All right. So now I have to get ready to go to this next class. So now if you want to go over some more word problems, we can either do it at the end of next class, or you can shoot me an email. We can set up another time to meet outside of class. But
All right. Sounds
yeah.
good.
Yeah, so once you try it out, you might realize that you didn't need as much help as you think. But if you do, like I said, shoot me that email and we can set up something.
All right. Thanks.
All right, not a problem, man. You all have a good one.
All right.
All right, take care. All right, everybody else good? I see 2 people still on. You good before I close out? All right, going.